for machine production process. So it's quite good. But some of the researchers in the world, they also ask if you remove the hydrogen, maybe the methane will reduce for the production rate, right? So that's why some of the my friend in UK, the Alan Gui, he is the pioneer for study the two-stage system, and he published the paper in the BT Bioresource Technology Journal, and showed that if we do the two-stage system, we can increase. We produce even small of the hydrogen production, but we can increase the second stage for the methane production around 30%. So it's quite good technology for this one. We will not reduce the methane production. We can enhance. Yeah, even we produce a little of the hydrogen production, but we enhance 13% of the methane production. So I think this is quite a good process. At that moment, Alan Gui used the GRACE, the hydrolysis of the GRACE. And then another friend in Italy, they study many kind of the co-digestion process, use the swan menu, mixed with maize silage, with the rice flour, olive pomace, and also with the fruit vegetable. They find all the two-stage system gain the more energy from 8% to 43%. It depends the different substrate. So it's quite good. Even for the co-digestion process, the two stages still can get more energy compared to the single stage. So in my lab, since 15 years ago, we studied this kind of the technology from the sugary wastewater, starchy wastewater, starch materials, and the ligno materials for biohydrogen production. Then most of the energy gain from the two-stage system are higher than the single stage. So we already studied this one and published many papers, and also the Professor Shinsu also joined some of the paper publication in this table. Okay, and then based on this kind of the information and also the technology development in my lab, and we joined some of the international conference and made some friends in Germany and also Italy. So this is my best friend in Germany called Hans, Ochernest. Yeah, but he is retired from this Institute of the Bioenergy and Agriculture Engineering because his age already more than 65. But right now, the new director for this State Institute is Andre, also my friend, and I send a student. Like you can see this slide. I have the friend in the left-hand side that my PhD student, and also the right-hand side there are two students, right? One of my master student, another one is a PhD student. For the PhD student is also from the lecturer from the ITB. Now he also published many papers in my lab, around 8 papers. So also like 6 Q1 and 2 Q2 papers. And then they study in University Hohenheim in Stuttgart cities in Germany. They use the whole full-scale system, not like in my lab. We just study maybe in the lab bench scale, and also some of the my research scale is go to the pilot system. But for the my Germany friend, they use the full scale. So it's quite more expensive to study this kind of the system. So I send students join together, so we can have some joint publications for with the University Hohenheim, and then this is for the National Research Council collaboration. We set up we signed MOU and set up the international innovation platform. We call the innovation platform. We more focus on the 4 topics. One is for the green product, another one for AI, another for the GIS, and also social science together. So there are many professors joined together. You can see this slide. They have my like the university chairman, the board trustee chairman also inside, and our rector, and the vice rector, and the many deans. Yeah, like the dean of the IOA, and the dean of the College of Informatics, and the dean of the construction, College of Construction, and the many professors joined together for this kind of the international innovation platform. And I also send the student to the headquarters of the CNR in Italy, and Professor Sinsu from Usman University, I also sent her to study in Italy for 3 months or maybe 2 months or 3 months. Yeah. And then that one is like a general information for this kind of the technology. But if we would like to know how to scale up the system, we have to do many research in the lab. And then after the lab, we have to go to the pilot system. Otherwise, for our industry partner, they don't believe our technology can implementation to the real size. So that's very important for the pilot. But for the pilot, we also need a lot of the budget support. So at that moment, we published one of the journal and the mentioned about the first ranking, first benchmark in the world for the biohydrogen production rate. And then our government and our university see where we are, and then support more budget to create a pilot in Fengsha University. And right now we have another pilot system in different country and different locations in Taiwan. Later I can introduce some. And then this is our benchmark models. I think this hydrogen production, biohydrogen production is still the #1 in the world. Yeah. Since 2006, no research team can catch up this kind of the numbers. But right now, we are not only focused on the high rate production technology. Right now, we also think about the low cost technology and how to make our system cheaper. Yeah, and then can realize in the real world. Yeah. So this is also quite important things to do in our lab right now currently. So this is the strategy for the reactor design and how to scale up the system. We have to study like reaction kinetics, thermodynamic, hydrodynamic modeling design, and the final selection for the technical and the economy group. Because if you are from the science point of view, you will think about how to increase the yield production and also the rate production of the biohydrogen. And then if you are from the engineering side, I think you are more focused on the production rate of the hydrogen. Yeah, because if you can produce the high rate of the hydrogen production, it means your size will reduce if we produce the same capacity of the hydrogen. And then, but the final, if you are going to the industry, your boss will choose which one is more economic. Yeah, which one is more economic for the process. Okay, and then so for the study right now, we have if you are studying the lab, first one you have to think about the kinetic study from the batch mode, and also for the continuously you will go to another field. Yeah, this one we call the hydrodynamic. And then if you combine together, we have to do this kind of the technology, combine the kinetics and the hydrodynamic, thermodynamic for the reactor design. So this is our study in the lab. Yeah, we will know the flow region, in the reactor, and also the different phase hold-out studies. So based on this kind of study, then we can design the reactor. So scale up the reactor, we have to go to pilot first. So this is the pilot system in Fengsha University since 2006 to 2010. Yeah, we study this kind of the technology in Fengsha, but right now we already moved to the real size. So for this kind of the system, we built it's around $1 million. Yeah, so I think it is quite expensive for the study of the pilot scale. We are not only for the hydrogen production, we also have the methane production together, and we also set up the MBR membranes bioreactors, and also use the LG to fixation of the carbon dioxide for the effluent of the gas production. And then we can get the pure of the hydrogen and also methane. So for this kind of scale, then the student can study this pilot system in Fengsha. This is the student from the master program of the environmental study, and also some of the students from the Department of Chemical Engineering and the Material Science. Okay, So for this one, final, we also set up the biohydrogen fuel refueling station in Fengjia University. Then we can use this kind of the gas inside into the fuel cell car. And we run this fuel cell car in Fengjia since 2010. And, and then the car can run if we use the fix of the, like we call the AB5 fixation of the hydrogen canister. This one, if we have the 6 tank, then can run this fuel cell car around 150 kilometer per hour. So this is the at later moment we have the promotion for this kind of the system, not only for the fuel cell car, we also have the refueling station. So this is the promotion time, and then we set up the system in the real size, in the wastewater treatment systems, and you can see the thinner one. They are for the hydrogen reactor, and the big one is the methane reactors. So for this one, we set up in the sugary waste water treatment plant, and another one we set up the system, the big one in the piggy farm. Yeah, at that moment, I think like some of the professors from Ulsan University also visit this one, and some of the government officers from Manado City. Yeah, they are joined together and they see this reactor. And but for before set up the system, we have to study like the hydrodynamic model and check the agitation system can go where, yeah, and work where. So for this one, we also have to design the process from the BFD to PFD and for the PNID. And for our industry partner, they can base on our design and then create this kind of the system. So we set up this one around 1 year, but from the beginning, maybe 1.5 years to set up for the design. So this one, you can see the bird view. It's quite beautiful for the real size system. And you can see the picky farm and then the biogas production system together. So the most important thing is the bacteria. So how to fit and cultivations well for this bacteria, I think it's quite good training in the lab. Yeah. So the final for use this kind of technology, we have a small pilot system also set up in the Manado City. So we combine together with the North Sulawesi government and the Manado City government and the Ulsan University, Fengjia University together through the APEC platform. So for the 2014, Manado City faced this big event, right? The flooding, even also Taiwan. 20 years ago, we also faced very big floodings. And then we relocated the people like Manado City also. Okay, at that moment, I met the Vice Governor Stephen in Wellington APEC Energy Working Group meetings, and then we know this kind of situation. So I tell the Stephen, maybe we can have some small scale pilot system set up in Manado City to show up this kind of technology can work in the remote areas. So that's why Ulsan University sent two professors. They are like a first trainer, yeah, in Fengjia University. And when they come here for the 6 months study, yeah, they learn a lot. Even not only for the biomass, they also learn about the solar panel, how to set up the solar panel from the beginning to the final. They also get some of the certificate. But for the training locations, they are under the government, Ministry of Laboratory, Ministry of Labor. They are the second level of the certificate. They can get that one, and then the student or all the trainer or trainee, they can use this kind of certificate and join some of the solar industry in Taiwan. Okay, and build up the solar panel. So also for the biomass energy process and the canister, we send a shipping from the Jakarta to the Manado City at that moment. Okay, so this one we call the system set up in the slaughterhouse in the Manado City. We call the synergy system, and this result and the outcome already published in 2000s, maybe 20, right? 2020, around 2020 in the Q1 journal papers. I think Professor Sinsu, yeah, worked very hard in these first journal papers. because we got a lot of the review comments and how to respond. Yeah, we also work until midnight to respond to this kind of the comment. So this is quite good model for the synergetic bioenergy system set up in the small villages. Okay. At that moment, we work together with Ústlang University, and there are some of the students from Ústlang University, and some of my master student, PhD student work together, and they also work in the midnight. Yeah, even our system come in the midnight. My PhD student, two PhD students, including Professor Shinsu, come together and wait for the chemist to come. Yeah, so I think that is a big stories for me. Yeah, in my research life. Yeah, there's also right now remember in my mind. Yeah, so there's many students come for visit this kind of the system. Yeah, in the solar house, and we set up this one. At that moment, the government also think about maybe our effluent can be the like a biofertilizer, can grow up the chili. Yeah, because at that moment, there's a chili plantations and find this biofertilizer can be good for the chili. Yeah, grow up, and then they try to use the solar dryer and make the chili become the powder. So it's quite good. Can produce the not only produce the energy and also can have some of the green product we can sell like the green chili. Yeah. Okay, for this one, at the moment we use this kind of energy to support the for the small church just nearby. We use the poo of the cow, right? Yeah, and also have like the banana peel waste. We mix together and set into the system. And you can see this student from the Ústlang University and my PhD student, they work together and then try to support this energy. Yeah, nearby, yeah, this one of the small church, he power the electricity to them, right? I think this generator just 3 kilowatt, but it depends for the substrate loading. Yeah, so later if we have more substrate, then we can scale up this system. Yeah, for our technology. Yeah. So you can see here, yeah, they have the two worker. Yeah, the government hired these two worker from nearby the slaughterhouse and maintains the system. And they right now they also work with the government and also help for this set aside area. And right now they also dissemination this kind of the system during the COVID season. Yeah, because the COVID season they cannot run this pilot system. So right now they can work there and use the small system and can produce the biogas and also can cook the banana and become the new product. Yeah, because they said that just use the 1/3 of the gas for the cooking, and another 2/3 can be the fuel for the fried banana. Yeah, cooking. Yeah. So this another system we already set up the system for the mobile. Yeah, two-stage biohydrogen production system. So you can see we merge all the system inside the canister and then easy mobile the system to the wastewater treatment plant. Right now, we also use this one, yeah, in some of the area in Fengjiang University. And then we have another pilot system. We use the municipal switch sludge and convert it into the hydrogen and the methane. And we use the steam reforming process into the pure hydrogen and use in the SOFC. So this process right now also very good. Then some of the university students from Japan, like Tsukuba University, they come together and also visit our pilot plant in the municipal wastewater treatment plant. And this one right now also have some the TV show just show up the last week, yeah, for the system. And we also prove of this concept. Yeah, you can see this SGS is the international validation system. they check out for our system. There can be like a 0 ppm of the sulfide production during our purification process, because for the fuel cell application they need 9.9999 of the hydrogen to use in the SOFC. And also you can check, see here, we run the system almost 1 year and get some of the data here, and then they sign here. So it means this kind of the pilot system can work. So right now we try to scale up the system in the municipal wastewater treatment system. Okay, and then this one is the biggest design for me right now. Yeah, because we work for another industry, but sorry, this one just for the Chinese words. But this is very big because we try to treat around 300 ton per day of the kitchen waste. Yeah, in Taiwan. I think this is also the biggest one in Taiwan that I designed for this one for the kitchen waste. Because of right now, Taiwan also very worried about the picky diseased. Yeah, they are maybe can be impact to very big GDP in Taiwan. So right now they don't want to the kitchen waste to the piggy farm. So right now there's a lot of the kitchen waste produced in Taiwan. We try to solve this problem, and also use our technology to produce the energy. And you can see we try to collect around 300 tons of kitchen waste per day. So this is the system we designed already. So maybe in the near future, next 2 years, you can see this system in Taiwan for the kitchen waste treatment system. Use our technology. Okay, I leave some of the video link here because they have some like a student internship in Manado City and a student internship in Thailand. And also I have one of the video they are taking from the National Geography. Yeah, so this link leave to you, and then maybe like homework, maybe you can link and to see. Okay, so this is the final slide for me. Thank you for your attention.
Thank you very much, Professor Chu, for the insightful and inspiring presentation. So now we will proceed to the question and answer session. So for all the participants who would like to ask questions, may raise her hand virtually or write their question in the Zoom chat box. So you can drop your question from the Zoom chat box or raise your hand if you have some question. So we will wait for a moment for the question from the participant, and please feel free to share your question or thoughts on the Zoom chat box. And perhaps while waiting question from the participant, please allow me to ask your discussion question, Professor.
Okay, no problem. Yeah.
I think last year we met at the APEC SABT program, and we visit the waste energy production.
Oh, you come to Taiwan?
Yes, last year.
Oh, okay. So you see the one of the big biogas plant, right?
Yes,
in
Professor.
Baipu. Yeah. That's also quite big. But for that one, it's just 100 ton per day.
Yes.
Yeah, 100 ton per day. But they already treat all the dry kitchen waste in Taichung City. Yeah. But right now I design for the wet kitchen waste. Yeah, the cooked kitchen waste for the 300 means the larger than that one 3 times.
Okay, so is it located at the same city?
No, another city. Yeah, we designed this one in the southern part. Yeah, southern part of the city near Kaohsiung.
Okay.
Yeah, another biggest city. Yeah, but we are not only treat one of the city or county. Maybe we can treat around the 3 cities. Yeah, kitchen waste. Yeah.
Okay, Professor.
Okay, can I have a question?
Okay, no problem. So you are Professor Sinsu, right?
Do you know me?
Yeah. Because I cannot see your face, but I heard your voice.
You cannot see my face? Oh my God.
Yeah. Right now.
Okay.
Okay. Yeah.
Okay. So I think So I would like to ask you about is there any possibilities for your institute or research center to invite students from Indonesia to have a maybe short visit? Maybe you can explain here if you have a program. And secondly, because this webinar is in the preparation of establishment of the new master's program in energy and environment. Do you have any insights to share to our audience here? How important it is to have the master studies in energy and environment combined to the, nowadays like climate change, sustainable development goal and something. Could you have some insights to give us? Thank you very much.
Okay. So for first, I think for the opportunity for the study or the short term of the exchange, I think right now currently we have one of the program called the TEEP, Taiwan Education Experience Program, since 2017, the first year I run this project, right? Professor Shinsu is the first time, and another professor means. Who come with you together? I forgot. Since 2017, we have the Taiwan Education Experience Program, right?
I was there in 2018.
2018, but the first I applied from the
2017.
But yeah,
Yes.
but for 2018 is the first time. At that moment, I have the 12 students from abroad, right, joined together
Yes.
for the TIP program, and then that one is my international connection. So normally I will not invite most students from single university. So I will invite more students from different universities, like from Thailand, Vietnam, Malaysia, and Indonesia, and also some students from Europe, right? So that's why when you come, you can meet different students here, and have the different cultural and the different research skill. So you can exchange your idea here in Fengjia. So this year, I also have one of the candidate to Usha University. So maybe your team can find the best student come with the tip. Okay. Yeah. So,
I
but
have
have
already.
to, I have to find the best. Yeah, because the candidate limitations. Yeah. So for that, because I also have to invite different student from different university and from different country. So that's why maybe every year I will share one quota to Ushuang University. So,
Good.
but yeah, but if the student would like to come for more like a different field, maybe I can ask for another professor to support, maybe more quota. But for that one, maybe every year we apply for this project before November. So maybe at later moment we have to discuss first, and I can ask another professor join together for the. Maybe we can open one of the webinar and ask them to give some quota to your university, like from different field, like from electrical engineering, right? And
Yes, that's
also
better.
informatics. Yeah, right. So yeah, that's why I have many friends in Fengjia University, like Feng Zhenlin from the college, is the secretary from the College of Informatic Engineering and Electrical Engineering, right?
Yeah.
So I think if you would like to get more quota for the student exchange, I think that's quite good. But for me, I also have another project called the IIPP. For the IIPP, there are only 3 months study here, but we can give more funding support. But for that one, I more focus invite a master or PhD student. Yeah, because that one is more important for paper publications.
Yeah,
So
yeah.
yeah. So that one, if you have the good candidate for the master or PhD student, maybe can join my IIP. But this year I also full. Yeah. So every year I will open 2 candidates.
Okay. How long?
Yeah.
For how long?
For study 3 months in Taiwan, but the
Okay.
funding support is more. Okay.
Okay.
Yeah, 3 times than the tip. Yeah, so I think it's quite good for the master or PhD student.
Sounds good.
Yeah, but every year I just have 2 quota. So this year I give one quota to Khon Kaen University, Thailand, and another quota I give the Citra, you know. Yeah, because the Citra, I think also from Indonesia is quite good, and he would like to study the master in my lab. So she would like to study, so I support for her. So this I already full of the candidate this year for the IIPP, but for next year maybe we can prepare for one from Usran.
Okay.
So for TIP and the IIPP we can have two, right? It's like but for the TIP maybe can like undergraduate, and for IIPP have to be master and the PhD student.
PhD
Yeah, so
student before
oh,
PhD or
oh, before PhD cannot get the PhD
yes,
already. Yeah, yeah.
yes.
So
I cannot,
yeah,
I
yeah,
cannot
yeah.
apply.
Yeah, yes. So yeah, already PhD
Okay.
cannot. Sorry.
Yes.
Yeah.
Okay.
So
That's
for
good.
that one, so for these two, I think I can keep two for Ushan University. If Ushan would like to get more, I have to ask another professor join our international platform, right? So maybe
Yes.
they can give more. But before November, I think that is the timing, because after November, we have to apply to the funding support from the government, like from Ministry of Education, Ministry of and for IIPP is a support from the National Science Technology Council. So there's a different project. Yeah. And I also have some project for the postdoctoral, right? Yeah, for that one, I think this year only one. Yeah. This year only one. But every year But every year I will invite two for that one. So maybe I can also share one from Usman. But that one we have to think about the best lecture, best lecture, yeah, from like a different country. Yeah, because I only have two. So I also invite maybe one from Thailand, Vietnam, and another one from Indonesia, like that. Yeah. So
Okay.
this for my project right now in the yeah. And then for the new department or new program for the environment and the energy, I think this is quite more important in the world right now, especially right now we face the climate change, right?
Yes.
Right now you can see that I set up one of the international network for net zero. Net zero eco-innovation means ecological innovation technology. We not only combine the academic professors, we also join the industry together. So how to solve the problem is not only study in the in the school right now.
Yeah.
So for the environment and the energy, I think if we set up this program, maybe we can have some industry partners also join together. And when the students study this kind of the program, they also will know what kind of the problem the industry faced. So that's why that's very important for the student if they learn the real project. So we call the real project, real problem, real project, and the real company. So that's I think we can think about the real problem set up from the maybe the industry, right? The industry have the real problem, but we set up project together, right? So the industry maybe support some funding, and we get some funding from the government and join this project, so-called real project. And the student can join this project, and the professor become the leader, like a PI, right? And then
Yeah.
after we finish this project, then can become the product or can become the process that the industry can be used. That one can become real company. So this I think also can set up this process, real problem, real project to real company. Yeah, inside the program. And I think for another process, I think also very good for the CDIO. Yeah, for the CDIO, I think Alisha know that for how to conceive, design, implementation, and operation. I think this kind of the idea also can set up in the new program. Yeah, because after we have the real project, I think not only study in the conceive and the implementation, right? We also think about more. Yeah, because I think I saw your program set up in the master program, right? So the student they already have the basic knowledge for maybe their background. But if join the energy and the environment, I think we have to open mind. Yeah, because right now the real problem is very complex. Yeah, we cannot solve the problem based on only one discipline. Yeah, So we call the multidisciplinary or even interdisciplines. Yeah. So these are very important. So if we like the energy and the environment setup, I think we can involve these two ideas: real problem, real project, real company, and this conceive, design, implementation, and operation process inside the program. Okay, that's my idea.
Yeah. Thank you so much, Prof, for your insights, and I hope everyone can hear that we have professor have some opportunities for you. So if you are you want to compete, then you have to compete to get that
Right. I need the
one
best one.
opportunity.
Yeah, I need the best one. Yeah.
Yeah. So if you want to try to compete, just let me know.
Yeah,
Contact me,
because
and then
the candidate limitation are limited.
Yes.
Yeah, so yeah.
contact me as a contact window here in Unstrat.
Right. Professor Shinsu is the focal point. Yeah, the focal point. Yeah.
Okay, thank you very much. And I
There's
return to
one question.
moderator.
Yeah.
Yeah.
Reynaldo. Yeah.
Okay.
Reynaldo.
Due to limitation, we will proceed to the next question. Here,
Andreas.
Reynaldo.
we have question
Ada
from,
dua.
I think 4 is Reynaldo.
Yeah, Reynaldo is the first one, and Andreas from Brin. Yeah, I think this symbol is from Brin, right?
Yeah.
Yes.
Okay. So Andreas Suli.
Hello.
Okay.
Hello.
Okay, thank you very much for the opportunity, sir. Professor Chen, my name is Cliff Reynando. I am from the master program in the postgraduate in Magister Management. As I have probably a simple question here, since we are about the green environment here. So it means that we're actually talking about the green air and clean air, right?
Clean air.
I just have a comparison. Here in Indonesia, we not only have a stock exchange here, but we all are also already have a carbon exchange here. My question is, if I look at the data from the internet, that Taiwan is also already have the carbon exchange, which called the Taiwan Carbon Solution Exchange. My question is how this carbon exchange is actually will impact to reach the net zero emission. So as that we know together, as long as this world, develop to become, better place. So there will eventually came a lot of the technology. So my question is how this carbon exchange could impact to our net zero emission target. If it's possible, then probably how long would it take? And probably you can make an example how much progress Taiwan's already make to this. Thank you very much, Professor.
Okay, I just simply respond to this question because I also worry about the carbon exchange. Yeah. Because for the carbon exchange, like in Taiwan, some of the industry they are not the real work focus on the green technology setup. Yeah, because they just buy the carbon exchange. So that one we call the green wash. So for the green wash, it's not good for the environment, because for the industry, if they are the big industry, I think they need to study the real technology like renewable energy also, or maybe they need to set up some of the technology to reduce the carbon is produced, right? The carbon production. It's not only buy the carbon, like from the exchange, officer. So I think that's not good only for the exchange. So if only the exchange, no one will do the real things for the like a real technology, right? Yeah, like how to set up the renewable energy technology in the company or in the factory. So we cannot only take care or think about the carbon exchange can save the earth. They need someone to do the real technology setup. So right now in Taiwan, if we check the green industry, if they just buy the carbon exchange quota, then they will not become the green industry. Yes, they have to something. They have to do something to reduce the real carbon dioxide produced. Cannot only just buy it. But because if they do a lot of the effort, but cannot go to the net zero carbon, right? So then they go to buy it. We also encourage them to buy the carbon dioxide, no problem. But they have to do what they can do. Yeah, like they can set up. Right now in Taiwan, there's a many the big industry. They set up the SDG divisions, sustainable divisions. They use the like a vice manager general's level to handle this kind of division in the big company, especially like a TSMC, right? You know, this is the biggest semiconductor company in Taiwan, in the world, right? They also set up this kind of division and they control all the factory. They have to do their effort to reduce the carbon dioxide emission. Even right now, they say their water, all the drop water, they can recycle to use 10 times. Yeah. So this is very high technology for them to study. So they also invest a very big amount for the renewable energy study and also the environment technology study inside the factory. So that's my idea. Yeah, and cannot only focus on the carbon exchange. Yeah, so we have to do our effort to do how to reduce the carbon dioxide emissions. Yeah. Okay, that's my answer.
Thank you so much, Professor. So, due to the limitation of time, we will proceed to the next question. Will be the last question for this session.
Andreas.
Andreas
I
Tulin.
saw
Yeah.
the Andreas name right now is
Yeah.
the new director, you know, the new director in the State Institute of Bioenergy and Agriculture Engineering in Germany.
Ah, okay.
Yeah, that's I say my friend retired, but the new director is Andreas.
Same name.
The same name, same name. So the
Okay.
Andreas is from Germany, right?
Okay. So please, the next participant, Andrea.
Yes, thank you, Professor Chen.
Yeah.
I'm sorry, I'm not your friend, maybe same name.
Same
Yeah,
name,
as you seen, my job is in National Research and Innovation Agency, RIN.
Yeah.
My question to you maybe about palm oil as bioenergy. What do you about palm oil as is it have potential as bioenergy for future? Because our president after Hormuz Strait after Hormuz Strait happened, we kind of need another resource for oil. So we kind of have oil palm. What do you think of it as a future bioenergies? Please give us your insight.
Yeah, so for the palm oil, you know, like I used to visit PTPN4, PTPN8. PTPN8 is nearby the Bogo, right? Bogo City. PTPN4 is near the Medan. Yeah, the Medan cities. So that I already visited there. And right now, BRIN used to be like a BBBT, right? You are from the BBBT or from LIPI?
No, sir. I'm from forestry department.
Oh, another one.
No, yeah, I'm not from.
Yeah. I know BRIN merged a lot of the research institute, right? And
Yes.
then the BBBT, they set up the one of very big biogas plant in the PTPN5 in Sumatra. They use the palm oil milled effluent. So I think right now for the palm industry, whole the waste that they already think about how to reuse or recycle, but only the palm oil milled effluent they just discharge to the water, and then right now they try to use the big lagoon system and then collect the biogas. But that's only the simple process to produce the biogas. I also asked them, maybe can try to use the two-stage system, produce the hydrogen and the methane together. Maybe can get more energy. But So as I know, there's Indonesia is the #1 palm oil, crude palm oil production in country, and then just a few of the palm oil mill effluent produce biogas for the energy production, like only PTPN5 only, I think. But in Malaysia right now, they have a lot already. Malaysia have a lot of the biogas production use the big lagoon system. But at that moment, just simple process, but I think also quite good because they already try to use the biogas energy by use the palm oil mill effluent. But for the crude palm oil right now, based on your policy, the national policy, you try to get more like a SAF, sustainable aviation fuel, right? And also the B20, B50 right now maybe I don't know already go to the B50, right?
Yes,
And,
for
yeah,
diesel.
yeah. Because 10 years ago I visit Indonesia just B10, like B10, B20. Right now already go to B50. Yeah, that's very high of the demand that you need the pure of the biodiesels. So right now also a lot of the palm oil mill transfer the crude palm oil into the biodiesel and sell to the like Europe. So that's one also better for the bioenergy, but it depends your national policy. Yeah, and right now I know you have a very big biodiesel program. Yeah, you have a very big biodiesel program. So that is from crude palm oil convert into the biodiesel. But for the palm oil, palm POME, palm oil mill effluent, this one can go to the biogas or biohydrogen gas. And it's interesting in the palm oil mill effluent. And that one can try to produce more biogas, and then the electricity generations can support to the nearby village. Yeah, so I think that is also quite good, can produce more energy because I know the CPO produce a lot, means palm oil mill effluent a lot in Indonesia. But I don't know, like, because as I know, like Professor Sinsu also study like a feed in terrific rate in Indonesia, still very least. Yeah, so that's why there's not a very big industry join the national project in Indonesia. So if a national policy for the feed in terrific rate can increase more, maybe there are some of the industry from Europe, Taiwan, Korea, Japan, they will move to Indonesia to help. Yeah, how to generate the green gas energy. Yeah. So that's my idea. So maybe can ask someone, they can set up the new policy for the feed in terrific rate. Like in Taiwan, our feed in terrific rate for the bioenergy, biogas energy increase around 50%. And then increase 50% is like means NT dollars from the 3.5 right now go to 7 NT dollars, double. And then there's a lot of the industry right now, they are very interesting to convert the like the organic waste into the biogas and go to the bioelectricity. So the policy can pull up, can push the industry, to go to the real company in Indonesia. I think that's a very important things for the some of the technology, move to the Indonesia. Yeah. Okay, that's my idea.
Thank you, Professor. We must use the waste from CPO back
CPO,
into the
right.
circle of bioenergy, right? Thank you,
Yeah,
sir.
POME, palm oil mill effluent. Palm.
Thanks.
Okay, thank you so much, Professor. So now, first of all, thank you so much for the enthusiasm from the participant. And let me close the first session. Thank you so much for Professor Chu for the excellent presentation and discussion. And ladies and gentlemen, let us give our appreciation to Professor Chu. Thank you so much, Professor.
Okay, thank you for your invitation. Yeah, I am quite happy to join your webinar. Yeah.
Okay, now we will continue to our second keynote speaker. It is my pleasure to introduce our second keynote speaker, Professor Novisar from Andalas University, Indonesia. Professor Novisar is an expert in agricultural and food technology with significant contribution in sustainable agriculture, life cycle assessment, bioenergy, circular economy, and environmental sustainability. He has been invited as a keynote and guest speakers at numerous international conferences and academic forums across Asia, including Japan, Korea, Thailand, Malaysia, Vietnam, and the Philippines. He also the executive chairman of the Asia Pacific Network for Sustainable Agriculture, Food and Energy, or SAFE Network, and has published extensively in reputable international journals related to sustainable and green technology. Today, Professor Novisar will deliver a keynote presentation entitled Circular Economy, a Strategic Roadmap to Sustainable Energy and Net Zero Emission. So, ladies and gentlemen, please warmly welcome Professor Novisar. Professor, the virtual floor is yours.
Okay, thank you very much, Dr. Salaki, for the good introduction. Can you hear my voice?
Yes, Professor.
Okay. Last week, I was invited by Dr. Sandra to invite me to give a speech on this webinar, and during the last week, I had many things to do. So yeah, I have to revise my two BIMA research projects, and deadline is yesterday. So I didn't have a PowerPoint presentation for this webinar, but I present in my work presentation. And thank you very much, Dr. Alicia, for inviting me to this webinar. That's I am very surprised that 300 participants joined this webinar. Congratulations for the event. Okay, I will share my slide. Yeah. This is the title of my presentation. Circular economy, a strategic roadmap to sustainable energy and net zero emission. In this title, we have three important keywords here: circular economy, sustainable energy, and net zero emission. I have 76 pages word, and I will share you after this webinar. And this is the content. Actually, I explored last night for this webinar. Okay, the content of my presentation is the first one is introduction. I would like to mention what is the problem about the climate in global and the challenge. And the second one is about background to see what is linear economy versus circular economy, and the third one, definition of circular economy, and for relationship between circular economy and sustainable energy. And we will talk a bit about the circular economy in the energy sector. and 6, strategic roadmap toward the net zero emission, and 7, key technologies supporting circular economy, economic and environmental benefit, challenge and barriers, policy and global initiative. We have field case studies here and future opportunities about the ocean. Okay, this is the keyword for the presentation. What is net zero? Net zero emission refer to the state where the total amount of greenhouse gases emitted into the atmosphere from human activities is balanced by an equivalent amount being removed. This balance is achieved by primarily through 2 approaches: deep emission reduction and residual offsetting. To achieve net zero, an entire entity, whether a country, company, or individual, must adopt strategies that not only minimize emission, but also remove or offset any residual gases. Yeah. How to calculate the net zero emission? Let's see this picture. In the left side, we have to measure to lower emission. For example, invest in green technology and measure to remove emission. It's equal to net zero, balance between amount of greenhouse gas produced and removed from the atmosphere. This is in the green one is greenhouse gas produced, and the blue one is removed from the atmosphere. This is net zero. And what is sustainable energy? Sustainable energy include any energy source that cannot be depleted and can remain viable forever. It does not need to be renewed or replenished. Sustainable energy meet our demand for energy without any risk of going bad or running out. This is why sustainable energy is the answer to our energy need. And what is circular economy? This is the definition of circular economy here. This is a system. Circular is a system, but encourages the reuse, this recycling and refurbishment of product and material such that there is minimum use of primary resources. The aim is to establish environmentally friendly production on consumption behavior by minimizing waste generation. So the point in circular economy is how to minimize the waste generation and how to convert waste into the economically valuable. Let's see this picture. How to compare linear economy versus circular economy. Like in the top one is linear economy here, like resource extraction. This is the chain from resource extraction here and production and distribution on consumption and waste. We don't care about the waste. We don't care about how to convert waste to a valuable product. We don't care about the environment. This is a linear economy. We only care about the production. And circular economy here, the circular, we have to recycle the waste and convert the waste into the economically valuable products and minimize the resources of the production and increase the environment health. This is the difference between the linear economy and circular economy. Why we have to care about our the problem? What is the problem actually? We know that the world is currently facing a serious climate crisis driven by increasing greenhouse gas emission, particularly CO2 from human activities. And these environmental challenges threaten not only ecosystem, but also economic stability, food security, and human health worldwide. This is why we have to care about the climate crisis by circular economy. Okay. Okay. The first one is because the global CO2 emission continue to rise with when we see this picture, 1956 here the emission is lower than 10, and 1979 is around 20 gigaton of carbon dioxide emission, and 1999 is around 25 gigatons of carbon dioxide, and 2019 is near 40 gigatons of carbon dioxide emission. So the increase of carbon emission is we have to care about that, because the impact of carbon emission is dangerous for a global environment. We know that the global dependence on fossil fuel, despite growing awareness of environmental sustainability, the global economy still heavily depend on fossil fuel as the primary source of energy. So continued reliance of fossil energy also delays the transition to a cleaner and more sustainable energy system. Look at the picture here. That's 3%. Yeah, we only have 3% electricity grid dependent, and 3% liquid electricity base, and more than 90% fossil fuel. So we depend mostly on fossil fuel. This also the problem. And the challenge toward net zero emissions. So because of that, this is the challenge toward the net zero emission. So therefore, achieving net zero emission require comprehensive transformation across energy, industrial, transportation, and consumption. And in this picture, challenges in reaching net zero is having realistic carbon target and breaking through a budget barrier, supporting supply chain, and choosing the right offsetting method. When process and structure are optimized, companies should implement proven method to offset emissions, such as direct air capture, which use chemical reaction to purify air and store it deep below sea level. Okay. And circular economy as a strategic sustainable solution has emerged as a strategic approach to addressing environmental and energy challenge. Unlike the traditional linear economic model based on take, make, and dispose, where we not care about the waste, the circular economy aims to maintain the value of products, materials, energy for as long as possible through reducing, reusing, recycling, recovering, and remanufacturing process. This approach minimizes waste generation, reduce resource extraction, improve energy efficiency, and lowers carbon emission. Resource efficiency, clean energy, and decarbonization are closely interconnected in achieving sustainable development and net zero emission. Okay, we go to the next slide. We talk a bit about the model of linear economy that take, make, and dispose. Yeah. Like here. So this is a linear economy model. Take, make, production, and use, and dispose. Take, we extract raw material from the earth and manufacturing the product from the raw materials, and use and consume products and discard as waste. So extraction of natural resources, depleted finite resources, environmental impact begin. So the impact to the environment start from the resource extraction. And from manufacturing products, we use energy and resources. Production of goods generate emission and waste. And during consume the product used for a short time, limited lifespan, no consideration for reuse on recovery. And the dispose or discard as waste, product become waste, landfill or incineration, pollution and greenhouse gas emission, loss of resources and value. Impact of linear economy, natural resource depletion, waste generation and pollution, greenhouse gas emission, economic vulnerability. And overall, the linear economy is no longer compatible with the goals of environmental sustainability and climate resilience. So we need for transformation toward a circular economic system. This system is essential for several reasons. reducing pressure on natural resources, lowering greenhouse gas emission, improving energy efficiency, minimizing waste and pollution, supporting sustainable industrial development, enhancing economic resilience, and resource security. So we have to move from linear economy to circular economy. Yeah. In the energy sector, circular economy support efficient energy utilization, renewable energy integration, waste to energy technologies, sustainable industrial production, reduction of carbon emission. So circular economy also aligned closely with SDGs, SDG 7, SDGs 9, and SDGs 12 and SDGs 13. Circular economy support affordable and clean energy, support and industry innovation and infrastructure. Circular economy support responsible consumption and production, and also support climate change. What is circular economy? Main principle of circular economy is one, reduce. The principle of reduce focus on minimizing the consumption of raw material, energy, and natural resources. Because more energy use, more material use, and more natural resources use, it will produce more emission. For example, energy efficient manufacturing, because more energy use will increase the emissions. So the energy efficient manufacturing is a good example of reducing the emission here. And the second example is reducing packaging material, sustainable product design, and minimizing resource intensive process. And the second one is reuse. Reuse refers to extending the life cycle of product, component, and material by using them multiple times instead of discarding them after single use. For example, here, a refillable packaging system, reusable shopping bag, repair and maintain service, second-hand product market. And the third principle is recycle, involve processing waste material into new product. So we generate the new product from the waste of our production. For example, here, like plastic recycling, metal recycling, paper recycling, and electronic waste recycling. And the four recovery principle focus on extracting valuable energy or material from waste and waste that cannot be reused or recycled. Example here, biogas production from organic waste, incineration with energy recovery, biomass energy utilization, recovery of industrial heat. And five, remanufacture. Example here, remanufacture automotive component, refurbish electronic devices, rebuild industrial machinery. So this table mentioned about the difference between linear economy and circular economy here. Linear economy based on take, make, dispose. Circular economy based on reduce, reuse, recycle, recovery. Linear economy relies heavily on raw material extraction. but circular economy maximize resource efficiency. And linear economy generate large amount of waste, and circular economy minimize waste generation. In linear economy, products are designed for short-term use. In circular economy, products are designed for durability and reuse. High greenhouse gas emission from linear economy practice and lower carbon emission from circular economy practices. Resource depletion in common in the economy, but in circular economy we promote resource conservation. In linear economy, we focus mainly on economic growth, balances social environment and social sustainability is practiced in circular economy. This is a main circular economy component here. Here, product design for longevity and durability, resource and efficiency and material optimization, waste prevention and reduction, reuse and refurbishment, recycling and material recovery, circular business model and digitalization, resource tracking, and need policy and regulatory framework. This is the form and circular economy component. Yeah. So what is the relationship between circular economy and sustainable energy? Yeah. The relationship is particularly important in supporting global effort toward climate change mitigation and net zero emission. One, energy efficiency improvement. This is the first can be achieved through cleaner production technologies, smart
akan menyaksikan adegan tong 3.3 NX tong
eco-design and lightweight material, efficient transportation and logistic, energy saving equipment and appliances.
Iya, coba teleponnya.
The second one is reduction of primary raw material consumption by reducing primary raw material consumption, energy demand from mining and extraction decrease, environmental degradation is minimized, resource depletion can be slow, production system becomes more sustainable. For example, here, recycling aluminum consume far less energy than producing aluminum from bauxite. Recycle plastic reduce the need for petroleum-based raw material. Remanufacture product preserve embedded energy and material value. As a result, circular economy help conserve both material resources and energy resources simultaneously. And the third relationship, waste to energy utilization. Technology include biogas production from organic waste, biomass combustion, anaerobic digestion, gasification, pyrolysis, incineration with energy recovery. This is the benefit, reducing landfill waste, lowering methane, replacing fossil fuel-based energy. And also optimization of renewable energy system. Okay, we have many slides here, so let's skip here. So this is the circular economy in energy sector. One is here is renewable energy system. Renewable energy technologies such as solar power, wind energy, and battery storage system are essential component of global transition toward low carbon energy system. Like solar panel recycling. The rapid growth of solar energy installation worldwide has increased concern regarding solar panel waste management. Solar panel contain valuable materials such as silicon, glass, aluminum, copper, and silver. So we can convert and reuse this material, and we can reduce electronic and hazardous waste, conserve valuable raw material, reduce energy consumption, support sustainable solar energy. Wind turbine material recovery, recycling metal component, reusing turbine part, recovering rare earth magnet, repurposing composite material, battery recycling and second life battery, and bioenergy and biomass, conversion of agricultural waste into biofuel like rice husk, palm oil waste, corn stalk, sugarcane bagasse, coffee husk. It can be converted into bioethanol, biodiesel, bio-oil, and biomass pellet. This conversion offers several advantages like reduce waste accumulation, provide renewable energy alternative, reduce dependence on fossil fuel, create additional economic value for agriculture. And biogas production from organic waste can electricity generation and have utilization of industrial residues.
Yes,
Many industrial process produce residues and byproduct that still contain energy value here.
Excuse me, Professor.
Yes.
Just about 10 minutes remaining for the
Okay.
presentation session.
Okay, thank you. So this is a strategic roadmap towards net zero emission. So the phase one is resource efficiency. The phase two here, circular production system like eco-design, linear production and recycling infrastructure. Phase three, renewable energy integration, and phase four, carbon neutrality. Okay, seven key technologies supporting circular economy: artificial intelligence for energy optimization, Internet of Things for resource monitoring, and digital twin and smart manufacturing, and green hydrogen technology, advanced recycling technologies, and economic and environmental benefit. The implementation of circular economy principle provide significant environmental and economic benefit, like reduction in CO2 emission, reduction on waste, conservation of natural resources, and economic benefit, production cost efficiency, and creation a green job, and development new industrial innovation, and national economic security. Challenge and barrier here, high initial investment cost. So circular economy practice need more initial investment cost here, and the limitation of technology is also the barrier. Inadequate regulation and policies in our country like Indonesia, low awareness among industry and society. This is the challenge and barrier. Limited recycling infrastructure is also the challenge, and policy and global initiative. This is the policy and global initiative on circular economy like Paris Agreement, SDGs, like here, and net zero policy in various countries like UK, targeting net zero emission by 2050. Japan also, Chinese targeting by 2060. Indonesia promoting energy transition and emission reduction strategies also. So the role of government, industry, academia, and society here, government play a central role by developing regulation and policy. Industries are key actor in implementing circular economy practices. Academia, university and research institution contribute through scientific research and technology development. Society and consumer play a crucial role through responsible consumption behavior. This is a policy. Okay. Okay. This case study here, for example, European Union Circular Economy and Action Plan. We can see it in our slide. Like Japan, recycling oriented society, and China circular industrial park, and Indonesia contact waste to energy project here is already starting biodiesel program B10 to B50. This is the future opportunities, green industrial transformation, and circular supply chain, and sustainable cities, and low carbon economy, and green investment, and SG financing. This is okay. Okay. We come to the conclusion. In conclusion, circular economy represents a strategic roadmap toward sustainable energy systems and net zero emission. By integrating resource efficiency, renewable energy, technological innovation, and sustainable industrial practices, circular economy provides a long-term solution for addressing global environmental and energy challenges. The successful transition toward a low-carbon future requires strong policy support, technological advancement, financial investment, and collaborative action from all sectors of society. Through collective global effort, it is possible to build sustainable resilience and carbon neutral for future for generation. So this is my closing statement. There is no net zero future without a circular economy. Sustainable energy and resource efficiency must go hand in hand. Thank you.
Okay, thank you so much, Professor Nafisar, for the insightful and inspiring presentation. Now we will open for the question and answer session. Once again, participants who would like to ask question may raise their hand virtually or write their question in the Zoom chat box. So please feel free to drop your question or raise your hand to ask directly to Professor Nafisar. So perhaps while waiting the question from the participant, Professor, please allow me to ask one short discussion. As we know, environmental issue and climate change have become global concern. In your opinion, how important is the circular economy approach in achieving sustainable development goals?
Yeah, because many participants here is Indonesia, so I can easily answer this question in Indonesia. So the question is how important circular economy here to improve the environmental and sustainable development, like that?
Yes,
Yeah.
Professor.
In circular economy, the basic principle is circular economy, how to make resources use is efficient is the one, because many resource use, many raw material use will increase the emission. This is the problem. And with the lower resource applications, so we need also the lower energy, because more energy use will increase the emission. So when we use low raw material, and we need lower energy, and lower energy will improve the environment, because we not not much emission produced from the energy. And the other principle here is regenerative. We can use the waste from our production and generate new product from the waste, like and we can reuse the waste from material used before. And so with when we use the previous material here, it's mean that we produce the lower resource extraction practices. So the lower resources use will improve the environment and sustainable development. That's it's my point.
Okay, thank you so much, Professor. So, what do you think? What is the major challenge in Indonesia, especially?
Yeah, in Indonesia, the major challenge is a policy. Yeah, we have a policy, and how to achieve the CO2 reduction. We adopt the Paris Agreement also, but in implementation we still slow in implementation, and also not many people care about the environment. So this is the challenge, is policy and also attitude.
Okay, thank you, Professor. I think one last question, because we provide this. Oh, okay, we have another participant, Andreas. So you can ask your question directly to Professor.
Thank you for the hello.
Yeah.
Can
Okay.
you hear me?
Yes, yes, sure.
Thank you for the opportunity again. My name is Andreas, and I'm from BRIN, National Research and Innovation Agency. Professor, I'm sorry,
Yeah.
Prof. We right now doing research about electric vehicle. I'm doing research with maybe one of your friend, Bu Rislima, if you know her.
Yes.
And my question to you about electric vehicle. What do you think? Do you think Indonesia is ready to transition to electric vehicle? What do you think the state of the readiness of the infrastructure to sustain the electric vehicle from regular fuel to electric vehicle? What do you think about the state of the state readiness of the infrastructure to sustain electric vehicle? Thank you, Professor.
Yeah. Yeah. The first one, my answer is the electric vehicle is expensive vehicle. So our economy is not too much support on the vehicle, because it's very expensive, and also we live in a big area with different land differences, and so we need to penyesuaian, adaptation on this technology, and yeah, it's need more than 10 years. I think to more than 10 years we can ready with the electrified vehicle. But uh, uh, my opinion, the cost is the first constraint on the readiness of application.
Okay,
Okay,
thank you.
thank you.
Yes, yes, Professor. Thank you for your insight.
Okay, thank you so much. I think we have one more question. I think this will be the last question from Haryadi Wijaya from the chat Zoom. Yeah. The rising usage of fossil fuel year after year shows a strong dependence. This trend creates serious environmental problems such as gas emission and climate change. How are sustainable energy policy formulated at the national level in Indonesia?
Yeah, we already start with bioenergy, convert the oil palm to bioresource is it's I think it's better practices for convert, and we also have many resources of sustainable energy and green energy, and like we have heat resources, and we have what is they call the solar and many resources. So we can use it better. I think in the future we can convert the fuel to another energy, but now we still depend on the fossil fuel.
Okay, thank you so much, Professor. I think due to the limitation of time, let me conclude our session. So, ladies and gentlemen, we have now come to the end of today's keynote session. Today, we learned valuable perspective on sustainable energy and environmental innovation from two outstanding speakers. From Professor Andrew Chen Yon Chu, we gain insight into the future potential of biotech technology and the importance of developing self-sustained energy community as a part of the global transition toward cleaner energy system. Meanwhile, Professor Novisar highlight the strategic role of the circular economy approaches in supporting sustainable development, resource efficiency, and the achievement of the net zero emission goals. This discussion reminds us that collaboration between technology, environmental awareness, industry, academia, and society is essential for building a more sustainable future. On behalf of the committee, I would like to express our sincere appreciation to Professor Andrew Chen Yun-Chu and Professor Novisar for their outstanding presentation and valuable insight. And we would like also thank to all participants for joining and actively participating in this international webinar. I will now hand the session back to our MC, Dr. Fabio Waro, for the closing remarks. Thank you very much.
Thank you, Dr. Joshua Salaki, for navigating this profound discussion. It is clear that innovation is not just an option, but necessity for our environment. Ladies and gentlemen, we sincerely appreciate insightful perspectives shared by our distinguished speakers, and huge thank you to all our speakers for their groundbreaking insight. Ladies and gentlemen, we have now arrived at the final session of today's program entitled Closing Remarks. It is our great honor to invite the Secretary of the Organizing Committee, Dr. Sandra Pakasi, to deliver closing remarks. Ladies and gentlemen, please welcome Dr. Sandra Pakasi. Dr. Sandra Pakasi, the screen is yours.
Thank you, Dr. Febo Waro. Honorable Director of Postgraduate Studies at Samratulangi University, Professor Dr. Insinyur Markus Lasut, as the host of this webinar. I'm proud of the keynote speakers, Professor Nofisa Nasir and Professor Chen Yun Chu. I respect to the entire organizing committee and extraordinary participant of this international seminar. Praise be to God Almighty for His grace and blessing, allowing us all together at the extraordinary event, the International Webinar on Sustainable Energy and Environment, with the theme Shaping the Future of Sustainable Energy and Environmental Innovation. On behalf of all the organizers, I would like to express my sincere and profound gratitude to all parties who have contributed significantly to the success of this event. First, to the keynote speaker, we extend our deepest gratitude to our esteemed keynote speakers. You have made invaluable contribution by sharing your inspiring and enlightening insight, knowledge, and experiences. The discussion and the presentation have broadened our horizons and sparked a renewed passion for continued innovation and collaboration in the fields of energy and environment. Your contribution are invaluable to development of our science and research. To the organizing committee, I would like also to express my deepest appreciation to the entire organizing committee, from planning to execution. Your hard work, dedication, and professionalism have been extraordinary. Without the support, synergy of each committee member, an event as magnificent as this would not have been possible. Thank you for all the time, energy, and thought you have dedicated to ensuring the success of this seminar. You are all a great team. To all seminar participants, almost 300 participants. And but not least, and last but not least, I big thank you to all the international seminar participation who came from various countries and backgrounds. Your presence and active participation in every session, discussion, and Q&A session made this seminar even more lively and meaningful. So we hope that the knowledge and network you gain over the past in this seminar, just maybe 2 hours, or thoroughly the seminar will be a great benefit, inspire collaboration, and open up new opportunities for the future. We recognize that there may be have some shortcomings during this seminar. So for this, we apologize and will continue to strive to improve the quality of our events in the future. We hope that what we have learned today will serve as a foundation for our continued work and significant contribution to society and global science. Once again, thank you to you, everyone. So let's continue moving forward together. Thank you. God bless us.
Thank you,
I
Dr. Sandra Pakasi, for the closing remarks. Ladies and gentlemen, before we conclude, let us capture this moment. I invite all participants and speakers to turn camera for virtual group photo. Let's show the world the face of behind the green revolution.
Okay, ladies and gentlemen, get ready for the first page. I'll capture the audience. Okay, get ready in 3, 2, 1. Okay, next page. Okay, get ready in 3, 2, 1. The third and the last page. Ready? 3, 2, 1. Okay, thank you.
Ladies and gentlemen, the symbolic presentation of certificates to the keynote speaker will be conducted by the chairperson of the organizing committee, Dr. Alicia Sinsure. Dr. Alicia, the screen is yours.
Professor Novizar has announced that this is a symbolic, so this is only symbolic, but the real e-certificate we will send to you by email after the chairman also assign it. So because we have to give the symbolic certificate to the keynote speaker, and Professor Chu already left the Zoom meeting. So I, on behalf of the committee and the postgraduate school of Samratulangi University, handed this certificate of appreciation to Professor Dr. Novizar Nasir as a keynote speaker. And thank you very much for all the insightful and very meaningful session that he conducted. Thank you very much, Prof. Noviz.
Ladies and gentlemen, we have reached at the end of our webinar today. Before we end, let me once again express my deepest gratitude to all speakers for the knowledge that has been shared and to all participants for their active participation. Hopefully, what we have discussed today can inspire us all to care more about the sustainable energy and environment, not only for Indonesia, but also for the world. Thank you also to the entire organized team who have worked hard to make this event a success. We hope that you all stay connected and continue the dialogue and cooperation to shaping the future of sustainable energy and environmental innovation. On behalf of the organizing committee, I would like to apologize for any shortcomings during the event. Stay safe, stay healthy, and see you at our future academic event. Thank you.
Thank you, everyone. Thank you very much for your attendance, and thank you very much. Don't forget to sign, don't forget to fill in the attendance, because with the attendance, you can get your certificate. So please find the attendance in the chat box and then please fill in. Thank you very much. Bye-bye. Jangan dulu off.
Thank you very much.
Jangan dulu.
Dr. Sandra, thank you.
Okay. Thank you, Prof. Novi. Thank you.
Thank you. But untuk attendance DP tanggal nggak bisa DP time valid.
Nanti tambah.
Coba deh.
Saya taruh 14 sekian ada di
Bisa klik tanggal 13, tapi ada jamnya.
ada jam. Taruh jam join itu jam.
Jam join.
Ada titik itu sebelah titik.
Ya.
Diisi semua DP
Kami
garis
ya,
itu.
orang masih kasih waktu untuk cek untuk ini
Tadi
Boleh,
tidak bisa
Prof.
12.30.
Gimana Dang? Sudah di-share lagi, coba lihat di chat.
Itu Dang, ada titik di tengah, jadi 14
Isi kiri
baru
kanan.
00.
Kita udah minta sampai jam
Kiri
berapa?
kanan
Kang?
isi.
Iya, di
kita
titik
suruh balik.
kiri, kiri kanan.
Oh, enggak apa-apa. Tunggu aja dulu. Biar Jo
Thank you,
dorang.
bisa.
Oke. Thank you. Indip ya.
Coba cek DP form. Boleh toh? Cek DP form seberapa orang. Dorang kan ada 200-an. 300-an toh. Share music. Sudah? Sudah. Semuanya, terima kasih banyak.
Makasih Encik Libi, panitia, makasih semua. Mantap.
Sukses.
Ci Eba, sukses.
Terima kasih banyak semuanya, sama-sama ya. Semoga sukses. Siapa tahu ada kesempatan-kesempatan boleh diambil untuk bekerja sama secara internasional. Kita mau salam-salaman dulu dengan panitia ini yang sangat luar biasa.
Lanjut untuk seminar internasional tahun depan.
Nanti Cik Stefa. Semangat.
Ya, semangat.
Semangat
webinar
semuanya.
ini.
Salam edukasi.
Oh, ini kok kita pe TikTok. Kita pe Encik ketua. Semangat.
Tunggu mau pegang tangan dulu.
Yang penting selalu puji Tuhan.
DP apa dulu? DP permohonan, sama yang tadi dah. Sama yang DP pertama.
Invalid time belum berubah.
Keluar kok.
Dari tendensi invalid time belum berubah, bisa jadi.
Halo Prof Danco sayang.
Halo.
Mohon maaf lahir batin.
Itu lagi.
Tapi puji Tuhan sudah terlaksana dengan baik dan benar.
Amin. Terima kasih, Istriku Profesor.
Luar
Mantap
biasa.
sekali. Terima
Luar
kasih
biasa.
banyak. Amin.
Ya. Oke.
Oke ya.
Ya, ini tadi yang hadir hampir 300-an orang, 300 lebih ya. Jadi tolong jangan lupa isi absennya supaya sertifikatnya bisa diterima. Terima kasih.
Libby.